In this segment I'm going to talk about circle properties, or continue talking about circle properties, and specifically about tangents to a circle and what kinds of things they can do. So I'm going to continue where we left off last time talking about chords, and a chord is from the edge of the circle to the edge of a circle in a line segment. This time we're going to be using a line instead of a line segment, so I'm just going to change that into a line segment. So there I've changed it from a line segment into a line. It goes continuing on. And we know that in our talk with chords that I can make a perpendicular bisector here. So if I take the distance from here to here and I ask to find the midpoint of it, but I can't do that in a line, but I can do it in a segment. So let me just modify that a little bit. So I've just made a line segment over top of that, and I ask the computer to find the midpoint. And so now I want to construct a line that goes across, or a line segment that goes across perpendicular to that. So I'm going to make a line segment perpendicular to that through there, please. And so there's my perpendicular line piece, and that produces an angle that we talked about before in our chord segment, and that angle is going to be 90 degrees. I'll just have the computer measure that to confirm, and it'll always be 90 degrees, and no matter where I move my chord, that's going to occur. So I'm going to hide some of these pieces, and then we're going to talk about tangents. So I've just cleaned up my diagram a little bit here, and I'll label the points here. So I have my line segment from U to R, and that's my chord, and we know that U to S and S to R are equal. We also know that RST is 90 degrees. So this line that goes through there is no longer called a chord. A line going through there is called a secant. And if I take my point and I drag it up, and drag it up, and drag it up, and so that point is only at one point. Now it goes through the circle at 2 points, still in 2 points, still in 2 points, but now when I overlap them, it's only touching it at 1 point. Right here, this line touches the circle at only one place. But notice my angle from my center to the circle to my line, in this case my secant, is always 90 degrees. So now it touches at only one point. This angle from the radius of my circle, from the center to the edge, is at 90 degrees. And now this line that we used to touch at two places now only touches at one place, and a line that touches a circle at one place is called a tangent. And so our tangent is a line that touches our circle at one point and automatically produces an angle that's 90 degrees. Anytime we have a tangent, we produce an angle of 90 degrees to the point across from the center of my circle called the radius. So the line from the center to the edge, which is my radius, is always going to be a 90 degree angle to my tangent. So I can now take another point and stick it, I don't know, let's say here on my circle. It doesn't really matter. I can move that point anywhere on my circle. So we've got it on my circle, and I'm going to connect and make another radius. So from here to here. And now what I want the computer to do, since I know a tangent is always 90 degrees, I want the computer to make a line through this point here that's perpendicular to this radius. So I'm going to construct a perpendicular line, and so now I've created a new tangent, and I'll just make sure that this is a nice solid color, and so now I've got two tangents now. And notice what happens when I move the tangents. I've got a tangent there, and I've got a tangent here, and I'll make this one movable too. And so here's our original tangent that we made with our chord, and now I've just transformed it. Oh, there it is again. We still have our line perpendicular to that. So there's our tangent here, and here we have another tangent down here. And what do you notice happens to our two tangent lines? Well, our two tangent lines cross at some point outside of my circle, right where the two lines meet, there. And that produces some very interesting characteristics. So I've asked the computer to calculate the angle from t to x to y, and that's 90 degrees. So that's this angle up here that we said was going to be 90. And the t to v to y, that's this angle here. That's going to be 90. And if I move my points around the circle, I still produce a tangent at the bottom, and I produce a tangent at the top. But when I produce two tangents, they come across the intersection. They intersect here at y, and I'm going to ask the computer now, go ahead please and measure from there to here and tell me what that length is. And it comes out to be 7.18 centimeters. Then I ask it to do the same thing from here to here, and it also comes out to 7.18 centimeters. Now, is that coincidence? Well, as I move this point up here, I notice that everything stays at 90. My measurement angle hasn't changed. My length from x to y changes to 12.62, but so does the length here. So it makes a very interesting triangle. Now this one goes right off the edge of the page. If I was to continue and drag this down, continue and drag this down, and continue and drag this down, we would end up getting, I'm off the screen here, we would end up getting our original point where the two lines cross. So whenever we take two tangents like this, they're going to cross at one point unless they are parallel to one another. And that is going to occur when our x point is right over here in my, if I have a diameter, in which case now a 90-degree angle to this and a 90-degree angle to this would produce two lines that are parallel to one another, and they'll never ever cross and touch and meet. So we don't have that here in this situation, and so they're going to meet. And so we make an interesting observation that my tangents cross equidistant from one another at this point outside my circle. Another thing that often happens in diagrams, if we take a segment, I take my segment from here to here, and now I produce a triangle here. And this triangle we know has a 90-degree angle into it, and this triangle down here has a 90-degree angle. So I've produced two right-angle triangles that we can now use Pythagoras. A squared plus b squared equals my hypotenuse, which is c squared, and do some calculations for that. So I can take my circle, make it larger, and notice that all these things still work. I got a 90-degree angle at top. I have a 90-degree angle here where my tangent meets my radius. I know the length of x to y is going to be the same as my v to y. I've created two right-angle triangles that are similar to one another, that are actually congruent to one another. So these are all properties of tangents on a circle. And along with the information around chords and inscribed angles, allow us to do many, many calculations and come up with many, many understandings with circle shapes.